Hi everyone. So we're going to start off our lesson of logarithmic and exponential equations. The following equality statements are useful when solving exponential or logarithmic equations. So given that x, L, and R are greater than 0 and C is not equal to 1 and L is equal to R, then log base C L is equal to log base C R. So if you have two different logs and the bases are the same and the two logs are equal, then their arguments are going to be the same. All right. So here we're saying if the left-hand side and the right-hand side are equal, if and only if the log of L is equal to the log of R. All right. So let's solve these using some carefully worded arguments here. A lot of these questions I am going to solve two ways, and you get to pick. So this question here, I'm actually going to solve it. It might look three different ways. I can put this straight into logarithmic form. And if I write it as a log, I can write log base 3 of 17 is equal to x. And that was really quick, right? So, and if I do that, my answer is going to be x is equal to 2.579. No, I'm just going to put approximately. X is approximately 2.579. Fair enough. And that's it. That's my answer. So that is using logs with base 3. I am going to use this of log, I'm going to pick this up in a different place, log 17 is equal to x. Now, I look to my calculator and I'm panicking because I don't have a base 3. I have a TI-83 and I'm not able to change the base to 3. What this enables me to do though, it enables me to use the change of base. So just the ratio of the log of your argument divided by your log of your base will yield the same answer. And wouldn't you know, x is still approximately this quantity. Now I'm going to use this another way. And this way is probably the most common way to use logs. And I may push you towards this way. What I'm going to do is I have 3 to the power of x is equal to 17. What I'm going to be doing is I'm just going to take the log of both sides. So on the left-hand side, I can use the power law, and I get x times log base 3 is equal to log 17. So only my left-hand side changed. And I used the power law to bring down my exponent, essentially. Notice how my 3 turned into log 3. So I'm going to divide both, to solve for x, I'm going to divide both sides by log 3. Keep in mind that that's just a constant. So x really is log 17 divided by log 3. And there's your answer. Anyways, all of these will equal to 2.579. Hope that's good. All right, let's move on to a different question. Now, I'm just going to warn you, this question scared me. It scared me hard. So maybe I'm just going to leave that up there and tackle this last. Right now, I'm going to look at 3 to the power of 1 minus x is equal to 5. I'm going to choose to solve this two ways. My first way is I'm going to solve this base 3. So I'm going to move both sides to base 3, and I could say log base 3 of 5 is equal to 1 minus x. By definition, that I'm just writing as a logarithmic. So I'm going to perhaps add x to both sides, and I'm going to subtract log base 3, 5 to both sides, and there's my answer that I get. X is equal to 1 minus log base 3, 5. So if I do that in my calculator, 1 minus and the answer that I get, x is equal to negative 0.465. And it's going to be approximately. So I could have done that using alternate means here. So that was using base 3. Now, get used to using base 10. So I'm just going to apply the operation of base 10 log to both sides. So the equation was equal, so if I just take the log, the equation's still equal. So on the left-hand side, I'm going to use the power law, and I see 1 minus x times the log of 3. Now, I'm just going to try to keep in mind that this is actually a binomial, and log 3 is a constant. And the right-hand side still remains as log 5. So what am I going to do? Now, the hard thing I think for many people to think about, log 3 is just a constant. So I'm just going to multiply my binomial by this constant. And what I get is log 3 minus x times log 3 is equal to log 5. So I'm going to isolate everything with an x to the left-hand side. So I'm going to keep minus x log 3 on the left-hand side. I have log 5, and then if I subtract log 3, if I subtract this to both sides, it simply moves over to the right-hand side as negative log 3. And I think we're almost done here. If I would like to isolate x, I'm going to divide both sides by negative log 3. So x is equal to log 5 minus log 3 divided by negative log 3. And that's my answer. And if you manipulate this, what you'll get is the same as what we had before.